this lecture video we are discussing about Woulf-kishner reduction and this Woulf-kishner reduction is also used to convert aldehyde or ketone into hydrocarbon or alkane. And when we take here this ketone CH3CO CH3, this is acetone, and when we react with this ketone or aldehyde with NH2 NH2, this is hydrazine in presence of strong base, here in presence of strong base NaOH, or this is sodium ethoxide, this is sodium ethoxide. This is also act as a strong base in organic reaction, or in presence of sodium ethoxide or NaOH, or simply what is the Woulf-kishner reduction? When a carbonyl compound aldehyde ketone react with hydrazine in presence of strong base give hydrocarbon, and it is also similar to that of Clemmensen reduction. Here CO group change into here CH3 CO group change into CH2, that means it give hydrocarbon, and N2 major byproduct N2 gas is obtained, and this is Woulf-kishner reduction. And now come to actual mechanism involved in this Woulf-kishner reduction. And at first in Woulf-kishner reduction what happened here, this NH2 this is hydrazine and two hydrogen from one of the nitrogen atom, and carbonyl oxygen from carbonyl compound react each other to give byproduct water. Then this carbon in this carbon there is dissociation of two bonds, in this nitrogen there is also dissociation of two bonds, therefore this carbonyl carbon and nitrogen form multiple bond. This is first step, and when this product is obtained, in second step what happen, the reaction is carried out in presence of strong base. Suppose when this sodium hydroxide ionized to give Na plus OH minus, or this sodium ethoxide ionized to give C2H5O minus Na plus, and ethoxide ion or hydroxide ion act as a strong base, and this hydroxide ion withdraw H plus. When this hydroxide ion withdraw H plus from this NH2 group, and here when H plus is removed, then this lone pair shift into nitrogen and there is development of negative charge. And again in next step what happen, this pair of electron or negative charge means one pair of electron shift in between nitrogen to form double bond. Here in between nitrogen there is formation of double bond, and when one bond is added from this nitrogen to this, here one pi bond shift towards this carbon, then here in carbon there is formation of negative charge. When this pi bond shift to this carbon develop negative charge, and when this lone pair shift towards this nitrogen to give double bond, here in between nitrogen there is formation of multiple bond, negative charge finally shift to this carbon, and here byproduct water. And when carbon develop negative charge carbanion from water molecule, this negative charge withdraw H plus, then here in carbon there is addition of hydrogen. And next step what happen, again base, from base, suppose from sodium hydroxide we obtain OH minus, this OH minus again withdraw this remaining one hydrogen from this nitrogen, and when this OH minus combine with this H plus, or this hydrogen is removed as H plus, again here give OH minus H plus give byproduct water molecule, and here nitrogen formation of negative charge due to shifting of this lone pair electron towards this nitrogen. And again what happen, this negative charge lone pair electron shift in between nitrogen to form in between nitrogen triple bond, and at the same time there is shifting of this pair, this carbon nitrogen bond dissociate, and this pair of electrons shift towards this carbon, then here formation of carbon contains CH3 CH3H CH3 CH3H, and when this pair shift towards carbon, here carbanion is formed, and here N2 there is formation of in between nitrogen, there is triple bond, this is N2 gas is eliminated. And next step again, what happen when carbon get negative charge, again this negative charge carbon withdraw one hydrogen from water molecule H plus to give CH2 group, means here CO group change into CH2, and there is reduction of carbonyl compound into hydrocarbon, and next byproduct OH minus, and this is Woulf-kishner reduction, and this is also effective for class 12 bachelor, BSc as well as for master's level.